Hello, and in this video I'm going to be taking the digital assets we created previously and setting them up inside a top network so that I can generate cliffs for the entire island. I'll also return to some of the digital assets and make some changes to fix any issues that I come across. Before we move on, let's just recap the process and what happened at each stage. So first off, we have our load landscape. This will load the separate height field layers, combine them together into a single height field. The second digital asset, height field extract cliffs, will take the ID layers for the cliffs and convert them to geometry. Then the cliff generator digital asset will subdivide and displace the geometry using height maps and Labs triplanar displays. Then we have some curvature and AO masks stored on as vertex color for use with the material inside Unreal. Finally, we have a digital asset that will split our large cliffs into smaller tiles ready to be imported into Unreal. The next stage is to take these digital assets and recreate this step-by-step process inside a TOPS network. Let's go back up to the object level and create another geometry node. Create a top network and double-click to come inside. If you aren't familiar with TOPS, these are task operators. We can create task nodes that generate work items, and then this scheduler executes those work items. And TOPS can utilize CPU cores to run multiple work items at once. And in this way, we can more efficiently process a large amount of data, such as we're going to do by generating lots of cliffs across a whole landscape. Let's add a HDA processor. And with a HDA processor, we can load in a digital asset to run as part of our TOPS network. And what I'm going to do is recreate this flow of digital assets inside our TOPS network. So I'll use the HDA processor to load in these digital assets and run them in turn. Let's rename these. Let's call this HDAs and this one PDG. And let's add another network tab. We'll have one for our top network and then the other tab for our HDA network. And let's pin these. So I can flip backwards and forwards between these two networks. And the first HDA I want to load is the load landscape digital asset. So let's load that in. Navigate to our package directory and select the digital asset we want to load, which is load landscape. And as soon as I did that, we've got this HDA Parameters tab. And it has all of the parameters that we exposed on our digital asset available to us inside the top network. First, make any changes to our digital asset to add additional parameters. On our HDA processor, I can click Update HDA Parameters, and that will reload the digital asset and add any new parameters to this tab. Let's come back to the Generation tab and come down to Asset Outputs. We've got an output file name here. This variable here, $PDG directory, refers to the working directory, which is set on our local scheduler, which currently says $hip, which is the path to the location of our current scene file where it's saved. So you can see this is the location of my scene file. And so currently all of our results from our HDA processor will be saved into a geo folder in the same directory as our hip file, followed by a file name, which we use also using some variables and an attribute called PDG name. Then I'm going to change this. We'll leave $PD directory /, but then I'm going to add $OS for a subfolder, and $OS stands for operator string, and that refers to the name of our digital asset. So now I've typed $OS, if I middle mouse click on our output file name, we can see there it says HDA processor 1. And let's rename this to O1 load landscape. And now that's updated. So that's going to be in a folder called O1 load landscape, which has the same name as the HDA processor. And I've added an O1 prefix because I want each of my HDA processors to be outputted to a set of folders that are clearly named after each processor. And I prefix this with 01 because I want each subfolder to be clearly labeled and ordered in the stage that it was completed. Now let's add a file name, and I'm going to use that same variable again, but this time we're going to include a backtick, $OS, close backtick, and then underscore, another backtick, and then at pdg underscore index backtick .bgo. We need these encased in backticks so that we can append them together with this underscore. And pdg index refers to the index of our work item. If I right click on this node and click generate node, this will generate a work item. And if I select that work item by clicking on it, it will go yellow. And now if I middle mouse click on the output file name and come across, you can see here we've got that 0, which is the index of this work item. And if I double click on this work item, we can get some information about it, and you can see here it says index 0. And I'm just going to add an expression here. So at the start of at pdg index, I'm going to add pad 0, open brackets, 4, comma, then close brackets after the pdg index. And now if I middle mouse click and take a look at our file name, we can see now rather than just being a single 0, it's padded to ensure that the integer length is 4 zeros. And this just helps keep things a little more organized when we come to generating hundreds of work items. Let's add another HDA processor and load in the next HDA, which was the high field extract cliffs. So on the HDA processor, I'm going to load in that high field extract cliffs digital asset. And for the output file name, I'm just going to copy the same output file name that we used in our first HDA processor and then paste it into the output file name of our second HDA processor. And rename this HDA processor to 02 extract cliffs. And so now this expression will save it into a subfolder with the same name as the node, followed by a file name to match. Now let's run these two nodes. Let's right click on the second node, and we have a few different options. We have generate node, which will generate the work items for the node, but it won't execute the work items. Cook node will execute the work items and generate the output files. Dirty this node will mark all of the work items as dirty, which will mark them as them needing to be recooked. So let's click cook node. And you can see when I did that, the local scheduler started running and it started to cook the upstream work items. We just got a tick, so we know this work item is complete. And then it began to cook the next extract cliffs, but it failed. And that's because on this HDA processor, we need to check create file inputs. So with this checked, this HDA will import the results of the previous node and then run. And then output the results for the next HDA in the process. So let's dirty and cook this node and let it run. And now you can see that work item is complete. We take a look at the directory, and now we can see we have these subfolders named after our HDA processes. And if we go inside, we can see the BGOs that we outputted as part of the process. And if we come up to our work item and right click, we can also view that work item output. Let's hit F to focus. Now we can see the results of our first node, which was to load the landscape. This has loaded the separate high-field layers and combined them into a single landscape and saved that out to disk. And then our second node extracted the cliffs and converted them to geometry. So if we view that work item, and then we hit F to focus the camera, we can see the geometry of our cliffs. Now, if you remember, at the end of this extract cliffs, we generate a piece attribute called class. And this assigned a unique integer to every single piece of geometry. And now I want to split these up into separate files so I can run them as individual work items inside of our TOPS network. To do that, I'm going to add a geometry import node. And let's connect our extract cliffs to that geometry import. First of all, let's set our output directory. On the storage tab, we've got external file path. Let's copy our output file name from our previous node and paste that and replace the external file path with that directory. And let's name this node 03 extract cliffs underscore split. And on the data extraction tab, select from copy from class, change that from detail to primitive, and we're going to create a work item for each piece attribute value. And by default, that piece attribute is class, which matches the attribute that we created in our digital asset on the extract cliffs. So what's going to happen is the geometry import will load the results of the upstream node, copy the primitive attribute to the work item, and then create a work item for each class attribute value. Let's just make sure we name this correctly. There we go. Avoid any spelling errors. And now, cook node. Now we have a work item for every cliff. And let's go back to our directory. And here we have that subfolder for extract cliff splits, and inside a BGO file for every single cliff. And you can see here we have 506 items, so that's 506 cliffs. That's quite a lot. I want to reduce this number whilst I'm testing the TOPS network and setting things up. So let's right click on the extract cliff separate node and come down to delete this node's output files from disk. And then we can hit accept. Now we can see that folder is now empty, so that's deleted those work items. Let's come back up to our extract cliffs and onto the HDA processor. And remember, we exposed this threshold for delete small cliffs. And if we increase this threshold, it will delete even more cliff sections until we're just kind of left with the largest sections. Let's just come back over to our network and select the height field extract cliffs and try a threshold value of 10,000. And we can see that's a good threshold. That's given us only the largest cliffs and deleted a lot of the small and medium-sized cliffs. So if we use this threshold in our TOPS net, that will give us far fewer work items to deal with, which will make testing quicker and easier. Actually, we've still got some small sections here, so let's just come in and change how this delete small parts is operating. So let's move this delete small parts. Let's rename it to delete small cliffs. And let's move it So we're blasting using the mask attribute to have just the cliffs. Then we're doing some cleanup. Then we're going to blast using the flow attribute, the flow mask, to split up the larger cliff sections even more. Then we're performing the clean. And then let's add this delete small parts cliffs after that clean. And then we can actually remove this second delete small parts. I'm just going to tidy up these nodes. So if we select all of these bottom nodes and hovering over the network view, holding A and left click, drag up. And that's neatly stacked all of our nodes together. Now this delete small parts, this delete small cliffs is working more as it should be expected. So now we need to save this. Let's right click, save node type. And that will have saved those changes to disk. So with that done, and we've determined that 10,000 gives us a reasonable number of cliffs to work with, let's come back over to our top net. And we're going to want to rerun this extract cliffs. So let's right click, delete this node's output files from disk, accept, and then on the HDA parameters, let's increase this to 10,000. On our extract cliff split, right click, generate node. Because our load landscape is marked as complete, it's not rerunning that, it's only rerunning the nodes and the work items that it needs to. There we go now. I have fewer work items to deal with whilst I'm testing this digital asset. And if we look at the directory, I now only have 31 files. And let's view one of these work items. Hit F, and there we go. That's one of our cliffs, ready to be processed, subdivided, and displaced. So let's do that. Let's add that cliff generator HDA. Add another HDA processor. Add that HDA file, which is the cliff generator. Under the generation tab, I want to check create file inputs. Again, we're using the upstream output files, and update our output file name. And I'm going to copy that from the previous node. And we need to name this O4 cliff generator. And on the HDA parameters of our cliff generator, I'm going to reduce that subdivision to 0, just to speed things up whilst I'm demoing. Right click on the cliff generator and select cook node. This node will take a bit longer to cook than the others, so we'll just let this cook and watch its progress. The dark green dots are work items that are completed, and the light green are work items that are in progress. You can see I've got 3 work items in progress. That took about 2 minutes to complete. When I ran this on the whole landscape and had the delete threshold about 500 with the subdivision level of 3, then this process took a few hours. In fact, sometimes I would just leave it running overnight and then look at the results in the morning. Let's have a look at the results of one of these work items. So I can right click on one of the dots and click View Work Item Output. And then F in the viewport to focus, and there we go. So we can see the geometry is displaced. It hasn't been subdivided, so it's quite low poly at the moment. We can also see we've got that vertex color, concavity, convexity, and ambient occlusion masks. Again, let's inspect the output directory. We've now got our cliff generator subfolder with our cliffs generated. And now we can load our final digital asset, which was the cliff split. So add another HDA processor and load cliff split HDA. Just as we did before, we're going to copy this output file name and paste this here. And check create file inputs because we wanted to use the results of our upstream nodes. And let's name this 05 cliff tile. So this HDA will split our cliffs into smaller tile sections for them to be imported into Unreal. And under the HDA parameter, we can set the grid size, so the size of the tiles that we're splitting our geometry into. So let's cook this node as well, right click and cook node. You'll see that the cliff tile has the same number of work items as it did in the previous node. And if we look at our subfolder and look in the cliff tile, we still have the same number of files of cliffs here. That's because this HDA has split our cliffs into separate sections, but it hasn't split them into separate files yet. We need another geometry import to do that for us. What I'm going to do is just duplicate this geometry import down here and plug our cliff tile into it. And we're going to call this 06 cliff tile split. And let's cook this node. Now that geometry import has finished cooking, we can see that it's taken the 31 work items, the 31 cliffs, and split them into 119 tiles. So that's 119 separate files to import into Unreal. If we take a look at our directory, we have that cliff tile split subfolder, and inside those 119 tiles. Now I could leave it like this, outputting these files into a single directory. However, when I cooked the final cliffs for the whole terrain, I had about 700 separate tiles, and that's a lot of files to have in one folder. If I needed to troubleshoot or inspect a single tile, that's a lot of files to scroll through. To keep things tidier and more organized, I want to group tiles together in subfolders. For example, grouping files together in multiples of 25 or 50. So on this geometry import, under the storage tab, I'm going to amend this external file path. I'm going to add a subfolder, and I'm going to write an expression that will take the PTG index and round it up to multiples of 25. To illustrate the expression I'm going to use, I'm just going to spell it out in using a spreadsheet, kind of break down what the expression does step by step. So I'll begin with our PTG index. So for example, I'm going to use the PTG index of, say, 32. And I'm going to divide that by 25. And then I'm going to use an expression called floor, which rounds the number down to the closest whole integer. And then I'm going to multiply that value by 25. So we're going to take the PTG index of 32 and divide that by 25, which gives us a value of 1.28. Then I'm going to use the expression floor to round that value down to a whole integer. So 1.28 gets rounded down to 1. Then finally, we're going to multiply that by 25, which gives us the result of 25. So what this expression will do is take our PTG index and round it to multiples of 25. So for instance, a PTG index of 3 gets rounded to 0. If we were to go above 25, say 26, that will get rounded to 25. Let's say an integer of 112 gets rounded to 100. Let's write this expression out in a single cell. First of all, we're taking our PTG index, dividing it by 25, Then I want to round that result down to a whole integer, and then finally multiply it by 25. And if I create a number sequence and copy this expression, we can see that expression at work on that number sequence. And so here, this just illustrates how this expression works and how when we get higher than 25, you can see here, it then begins to group these together in layers of 25, forward to 50, forward to 75, and so on. And I use spreadsheets quite a bit in this fashion just to spell out and break down an expression step by step, so I can clearly see what's happening if I'm troubleshooting something or I want to be clear that I'm doing something correctly. So let's write out this expression in Houdini. So let's select our geometry import and come over to the storage tab and take a look at this external file path. And I want to add an additional subfolder. I'm going to add 2 backticks. And then within those backticks, type pad0, close brackets, 4, comma, close brackets. So within this pad0, I'm going to write out that expression that I typed out in the Google spreadsheet. So let's type in floor, open brackets, at pdg_index, divided by 25, and then close brackets, which closes our floor expression, and then finally times 25. So that takes the PDG index, divides it by 25, rounds it down to the closest whole number, and then multiplies it by 25 to set it to a multiple of 25. Now let's right-click, delete this node's output files, let's hit accept, and right-click, cook node. And now that's done, let's take a look at that folder. Now we have our output files grouped together in multiples of 25. Now that concludes this video. In the next video, I'll be converting this top network into a digital asset that can either be run from Houdini or imported into Unreal and ran with Houdini Engine.